can be changed or adjusted, either by turning a shaft or sliding a contact. The maximum value is usually molded into the component body. Along with the letter R, the reference designator for variable resistors may be VAR or ADJ. Variable resistors typically have a non-symmetrical lead pattern that only allows them to be installed in one way. Now let's examine capacitors. Capacitors are the most widely used component in electronics. They also have the greatest variety of shapes and sizes. The basic function of a capacitor is to store and discharge electricity. A unit of electrical capacitance is called a farad. The three most common units of measuring using farads are microfarads, nanofarads, and picofarads. The picofarad has the smallest capacitance value. The value and tolerance of the capacitor is either printed on the component or is calculated by decoding color bands or coded numbers into numerical values. As with resistors, the Component Identification Desk Reference Manual contains a color code chart for capacitors and an explanation of how to read the color bands or number code. Again, it may be important that you understand how to decode the color bands and numbers so that you can determine the value and tolerance of a particular capacitor. Capacitors are either non-polarized or polarized and are designated by the letter C. Non-polarized capacitors can be installed in either direction. They are usually small and have low electrical values. They come with either axial or radial leads. Polarized capacitors also come with either axial or radial leads. The positive lead, or anode, will usually be indicated by a plus sign. This same plus sign is usually on the circuit board. There may be other types of markings to identify polarity on the capacitor. There are also variable capacitors. These types of capacitors can be tuned to a particular value depending on the function required. The part number and value range is usually marked on the component. Along with the letter C, the reference designator for variable capacitors may be CVAR or CADJ. Variable capacitors often have a non-symmetrical lead pattern that only allows them to be installed in one way. Sometimes the component shape is outlined on the assembly drawing to show orientation. Now let's turn our attention to diodes. Diodes are semiconductors that allow electrical current to flow in only one direction. The reference designator for diodes is CR or D. All diodes are polarized components, meaning it is important to install them correctly. Polarity is usually indicated by a ring on the cathode or negative end. An arrow may also point to the negative end. Another type of diode is called a light-emitting diode, or LED. LEDs emit light and are typically used as display indicators on the front panels of electronic equipment. The reference designator for an LED is usually DS, although they may be identified by LED, or by the diode designators CR or D. LEDs usually have radial leads. Polarity is typically indicated by the location of the cup and spoon inside the lens. The cup is associated with the cathode or negative lead. In some LEDs, the negative lead will be shorter, or there may be a plus symbol on the positive side. The last component we'll be examining in this section is the transistor. Transistors are discrete components that amplify electrical signals. The reference designator for a transistor is usually the letter Q. Orientation may be accomplished by matching marked pin numbers on the transistor to pin numbers on the drawing or circuit board by locating pin 1 to the right of the tab on a transistor can, or by matching the component shape with the outline on the circuit board or assembly drawing. Sometimes the pattern of holes on the circuit board indicates there is only one way to install the transistor. Let's stop again and review the material we just covered. The last section of Part 1 will examine the remaining through-hole components and connecting hardware. They include inductors, transformers, and other coiled components, filters, fuses, switches, crystals, voltage regulators, thermistors, connectors, sockets, headers, and jumpers. We'll start with inductors. Inductors consist of a coil of wire that creates a magnetic field when current flows through the coil. The reference designator for an inductor is the letter L. The magnetic field produced by an inductor is measured in henries, either microhenries or millihenries. The inductor value may be either printed on the body of the component or calculated by decoding the color bars on the component's body into numbers. Again, the component identification desk reference manual contains a color code chart for inductors and an explanation of how to read the color bands. There is no required polarity for inductors, and they usually can only be installed one way. Closely related to inductors are transformers and other coiled components. These components also create magnetic fields. Transformers and toroids use the letter T as a reference designator. Chokes share the letter L with inductors. There's usually only one way to install transformers, and the part number and value may be marked on the component. Watch out for those coiled components that are designed without that information. Variations in wire gauge, number of turns of wire, wire spacing, internal diameters, numbers of wires, and sometimes the use of ferrite or other types of cores can change the part numbers and values. Check with your supervisor when you have trouble identifying a component. Now let's take a look at filters. The function of a filter is to allow some signals to pass and to block or filter out other signals. The reference designator for a filter is FL, and there is usually only one way to insert the leads into the holes of the circuit board. Fuses and circuit breakers protect a circuit from electrical overload by intentionally failing before the overload gets to the circuit. A circuit breaker is a fuse that can be reset after failing. The reference designator for a fuse is the letter F. CB designates a circuit breaker. These components are measured in amps and may also have a voltage rating. The value is usually marked on the component along with the part number. Now we'll talk about switches and relays. Switches and relays open and close circuits. Relays are electrically operated switches. The reference designator for a switch is the letter S or SW. A relay is usually designated by the letter K. These components are measured in amps and volts and utilize a dot or notch for orientation. Our next component is a crystal. Crystals produce a consistent electrical pulse similar to the ticking of a clock. They are available in through-hole or surface mount packages. Crystals are usually designated by the letter Y. They are measured in frequency, such as kilohertz or megahertz. A chamfered corner or a dot indicates proper orientation. Now let's examine voltage regulators. Voltage regulators keep voltage constant in a circuit by minimizing peaks and valleys. The reference designator is VR, and there is usually an angle on the body or an indented dot for orientation. The last electronic component we'll discuss is the thermistor. A thermistor is a resistor that changes value based on the temperature of the component. The reference designator for a thermistor is RT. It can be inserted into the circuit board in any orientation. Let's complete this section by discussing connecting hardware. This hardware is available in both through-hole and surface mount package styles. Connectors are attached to a circuit board so that wires, cables, and other outside connections can be made to the assembly. The reference designator for a connector is usually the letter J. Sometimes the letter P is used. Connectors are oriented based upon a bevel, notch, or pin number molded into the package. Another type of connecting hardware is a socket. Sockets are soldered onto a circuit board so that an IC or PGA can be plugged into the socket without being soldered. This makes it easier to remove and replace a component that might be upgraded or changed in the future. The reference designator for a socket is some variation of the letter X. Sockets usually have a notch or dot to indicate orientation. The component being plugged into the socket will have an identical orientation mark. The next type of connecting hardware we'll discuss is the header. Like connectors, they are used for outside connections. Headers usually don't have a housing around their pins. They also use the letter J or P as a reference designator. Headers usually have alignment or locking tabs for the connector which mates with it. The last type of connecting hardware we'll examine is the jumper. Jumpers connect two pins on an assembly together, providing an electrical path between those points. The reference designator for a jumper is W or E when the jumper is a wire, and the letter P when the jumper is a plug. This concludes part 1 of this video. Surface mount component identification begins on part 2. Surface mount components are designed so they can be placed directly onto lands on the circuit board, as opposed to being inserted through mounting holes in the board. They have the same types of electronic functions as through-hole components. Many through-hole components have surface mount equivalents that are much smaller in size. What this means is that more electronic components and functions can be present on a small-sized circuit board when surface mount components are used than when through-hole components are used. Surface mount devices use the same system of part numbers, reference designators, and component values and tolerances as through-hole components. And the indicators for polarity and pin 1 orientation are also similar. What's different is that surface mount assembly is more compatible with automated processes than through-hole assembly. Because of their size and shape, many types of through-hole components require manual insertion. Almost all surface mount components can be placed by machine. The components come packaged from the manufacturer in one of 3 forms: on tape and reel, in tubes, or in waffle trays. Let's take a look at how each of these methods of packaging is loaded onto a placement machine. Notice how the operator checks the part number on the reel against the bill of materials. That's because these components are too small to have part numbers marked on them. In addition, polarity or pin 1 orientation should be verified before loading tubes into feeders. It's also important to check pin 1 orientation when loading trays. Another difference is that surface mount components don't have long leads.